Hi guys, I'm giving a contest after a while. I hope I do good. I haven't practiced any problem or so, but I think I can still solve these problems because I know how I solve them, right? So I believe I can solve the problems. I can take a gap and after 15 years I can solve these problems. My maturity is lying to my fuck. Let's consider the problems. How many do we have in total? Mm, Marisa is a girl of integrity who always helps others safeguard their belongings. Over a period of N days, she comes each day to take one of Raimu's takeouts. The eighth takeout is described by its deliciousness value WI, either 0, 1, or 2, forming a sequence of length n. Marisa has a special fondness for the number 3. She can perform the following operation 0 or more times. Select a non-empty subsequence of W whose sum is divisible by 3 and remove the elements of the sequence from W. Any select non-empty subsequence whose sum is divisible by 3. Determine the maximum amount number of operations um, Mirasa, Marisa can perform. So we want maximum number of operations, right? So if that subsequence is having 3, separate that. So 3's will be unique, okay? Oh, there is no 3's. Okay, if the subsequence is having 0, separate that. And if the subsequence are having 1, now it must have a 2. So it is number of zeros plus minimum of 1 comma 2. And then if you have remaining twos left out plus remaining twos by 3 seal floor, you can say greedily this is the optimal. Let me just do this. If c1 greater than c2, swap off c1 comma c2, this is better. And the answer equals to c0 plus c1 plus, oh, looks like there are nice problems, c1 c2 even e2. I think they are nice problems because c1 c2 are always nice problems in a sense that we have two levels, right? So it's nice. My maturity is like Remilia, weird names, is trying to escape while Reimu wants to land the final hit. The playing field consists n positions arranged in a circle. For each positions I and I plus 1 are adjacent and position 1 and are also adjacent. Initially at time 0, Reimu is at position x1 and Remilia is at position x2, where x1 not equals to x2. Each second, the following happens in order. Remilia either moves to an adjacent position or stays in the same place. Over the entire game, she may move to an adjacent position at most k times. Okay. After observing Reima's action, Reimu either moves to adjacent position or stays in place. If they are at the same position after both actions, Reimu catches Reimu and the game ends. Okay, it's just a circular thing. So either initial distance between them might be this or this. I don't think circle matters that much, right? So the minimum distance is what one guy will try to run away from, and the maximum distance is what the other guy will try to catch, right? So you can always moving in the front, moving first makes sense. But what if this guy doesn't move? Sometimes not moving may be good. You have to think about this properly, because I thought if you're in this corner, see, the game is move to the opposite side is always good for the remila. Okay, you can simulate this easily. Think of the simulation. If the remila is completely opposite direction, she doesn't just travel this side, she keeps moving this side, and once this guy comes here, she moves this side. Okay, and then that guy comes here, and then she keeps moving this side. So let's be clear. She tries to move to that opposite direction of this guy. Okay, if she is not in that corner, she tries to move towards that, and he tries to approach her better, right? Let's just take not in that corner, so not diametrically opposite. So he moves, he also moves, she moves, he also moves. Just this is the syntax. And after k moves, the position becomes same, and then whatever the minimum distance is there, that will be the answer. But imagine in an even degree case, then both will be in the opposite direction. She moves, he moves this direction. Now the distance became. హలో నేను కంటెస్ట్ రాసుకుంటున్నామా బాయ్ డివిజన్ 2 ఉంటాలే బాయ్ yeah now he will try to approach, right? Now the game has changed again, because now the game became the minimum distance has become like this. So he moves, she moves, he moves, she moves. Okay, now think about the other case where odd case where okay, both of them are there. Now uh, you 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 would ideally want to maintain the max distance itself, right? Because if you come this side, he will come this side, so you will try to move this side, and that guy will come here. From now onwards, the game has again fixed. Yeah. So you have to just mimic one move, after that game will become fixed. Got it? Remu is at position X, Raimila, the one who runs away, is at position X2. And you have K capping things, okay? And once after one move, you know what should happen. K minus minus will happen, let's say, and then for K moves, it's simpler, and then the absolute distance between them will be the answer, okay? I'll write the solution a bit. Min dish in circle is greater than or equals to n by 2. We do a move, and after that answer equals to k plus mindest. So let's just separate that case out completely, okay? If abs of x1 minus x2 is greater than or equals to n by 2, okay? K can be 0. Let's just separate that case first. Now what? You have to do one move first, okay? After that one move, it will become k minus minus. Okay, now I have to be careful. Odd or even. Based on that, this will reduce, I think. Minus n reminder 2. If n reminder 2, what happens is it's odd. You do this, okay, once. Now it became distance has become minus 1, right? And then he do that. So distance has become minus 2. Okay? Okay, if it is these two things, you will try to move that side. Now this guy will come this side. Then distance has become minus 1. N is greater than, okay, n equals 2, let me think of it. Wait, you can just stay there for out case. You will just stay there and this guy will move here. So for both cases, it's just the same. Yeah, just minus 1. So it's just greedy and simple simulation, okay? It's a simple simulation. But you have to do it clearly. It's demanding clarity, okay? It's demanding your clarity, how well you will clarify things. Because if the starting minimum distance is less than half, it makes sense to move this sir, and then once the k ran out, after k moves, once the k ran out, the other guy will just go and catch. The only problem now is like what is the state that doesn't say this one, which is opposite, diametrically opposite. Those are the only states that doesn't specify what to do, right? So you have to think about them, and once you think about them diametrically opposite, once you can immediately see he will just stay there, and that distance will become less than half, and then it makes sense. Like after that, it's fixed. After that, moves will become fixed. K minus minus min distance will be reduced by 1 because that guy will always approach her or him. I hope there is no mistake in there. Let me read these two things and then I'll try to read even and e2. Let's keep D for somehow. My maturity is lying my face. This is the eighth version of the problem. The difference between the versions is that in this version, n equals to 2, you can hack only if you solve all the versions of the problem. Okay, in this version, n equals to 2, you can hack only if you solve all the versions of the problem. You're given an non-negative integer a and a non-empty, strictly increasing sequence of digits d of length n. So we have a strictly increasing sequence of digits d of length n, where di less than or equals to 0, less than or equals to 9. Then how can n become, yeah, n is at max 10, right? Because if you have only that many digits. Find the minimum value of modulus of a minus b over all non-negative integers b whose decimal representation contains only digits from d. So n equals to 2 means you have at max 2 digits. You have to find the minimum value of modulus of a minus b over all non-negative integers b whose decimal representation contains only digits from d. All non-negative. So 0 is allowed. Okay, you have a number a and you have a set b, set of elements b, which can be just formed with using that digits from that d, right? You have 2 digits in this case. Okay, using those 2 digits, what all numbers can you form and what number forms closest to a? So you want smallest number greater than a, you want biggest number less than a. That's the problem, right? Because find the minimum value of modulus of a minus b, have those two cases. So what is the smallest number greater than a? Try to think about that first. Smallest number greater than a. Using these 2 digits. Should you be greedy? because those are the only digits that you're allowed to use. uh, you can be greedy. Okay, keep bigger number in this digit, and then keep all the so you can try what's this. So the number of digits you can try to minimize first. Okay, just try to see if there is a number greater than this with the minimum number of digits. Okay, that would be highest number filling up the digits. And once you have that highest number filling up the digits, you have something that is greater than or equals to this. Okay, the first thing that is greater than or equals to this. So you have that. And then you want something else, the first thing that is less than or equals to this, the biggest thing that is less than or equals to this, where you will put all d1s less than or equals to that. Okay, now what would you do? So we have one thing above, one thing below. So all d2s, all d1s. Okay, and once you have all d2s here, and once you have all d2s here, this is the first thing that is greater than or equals to that, right? You minimize digits. Now you have to minimize the first number, right? Try to reduce the first number. And once you reduce the first number, if it is possible, you are great. If it is not possible, this is the answer. Okay? And if it's not possible, now move to the next number. And so on. Done. Okay, now think about this one. You fix the digits. All of them are D1. Try to increase, not this one. Not this one. Now let's say all of these are D1s, right? Now you want to maximize this. Will the same idea work? If this thing, after you increase this, if it is less than that, you will increase that. Because let's think of the first thing, after increasing that, you're less than that. If you're never increasing that, whatever you increase here is worse than this, because base 2 itself is worse, base 10 is even worse, right? So greedy will work again. Try to find the smallest thing you can increase, and then you have increased that. And then try to find the next smallest thing you can increase, and then you have increased that. So it's simple. It's quite simple. If you have number of digits, you will follow the greedy procedure again the same way. Start with the highest digits. Okay, try to reduce as much as you can while making sure the whole thing stays above, and then again do the same, and then again do the same, and then again do the same. So both versions are solved together. Let me read C2 to a bit. Yeah. Mm-mm-mm-mm. Maybe. I'm not sure. 99999 18 times. So 9 is 17 works, right? Is 99999 17 times is less, 18 times is less than 1e18, so it works. In the worst case, it works. Okay, answer plus equals to, okay, now we have max. Okay, after having max, what should we do? We have to start from this idx. Let's remove this digit and then try to construct again. Okay, answer minus equals to p10 of I times d of n minus 1. Okay, I removed this digit. Now we will add it. Ah, we just want to know the smallest thing that works here. That's it. Right. If answer minus p10 of I times d of n minus 1 plus p10 of I times dj greater than or equals to a, then answer equals to, I also should break. It anyway works when j equals to n minus 1, right? Otherwise, the answer equals to, you remove that digit and then you add this digit. The smallest digit there, it will give you the smallest number, and then you keep doing this. So you have your maximum thing. Let's say if final answer equals to 1e18, and then f final answer will be minimum of f answer comma answer minus a. Okay, now again make answer equals to 0, idx equals to 0. First find the smallest largest digits less than or equals to a. You keep adding d0 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 d0. Let's be clear here. less than or equals to a. Only then we will add it. So you can add this digit, you can add this digit. So you are in that position now. Hell no. We keep adding. Here also we kept adding, and once it became bigger, we just broke. Now what? Start from here, greedily increase. Is it allowed to use Copilot? Let me check the solution. I'm reducing the minimum thing and then I'm trying to add the biggest one, and once it becomes less than or equals to 0, I'll just break because that's the maximum digit, right? See guys, I got the solution. Is it me or AI solving, or has Copilot suddenly become so strong? My maturity is lying. I don't want to make two wrong answers. What the fuck? Oh,
Yes, yes, yes. So yeah, that also happens.
until K moves, the distance remains same, and after that, each second distance will become reduced, and then they'll meet.
Yeah, bro. I did not.
Wait. If n equals to 2, maybe there is some weird thing happening. If n equals to 3, you can come here, and then it's done. K doesn't matter. If n equals to 4, then you can retrace. But if n equals to 2 or n equals to 2 and n equals to 3 has some weird issues here. I should have handled them. I thought so. I thought of looking at them, but then it looked like fine for me.
What you eating?
So n equals to 2,
Can you give me 10 minutes of
see out whatever the shit k is, you are done. What about n equals to 3?
ugly again?
Whatever the shit you do, you're done. And from here onwards, you will have three options, right? So you will just stay in the for. Whatever this guy makes, you can go for a run. I should have proved more clearly. I thought of thinking about that, but then I haven't. I haven't fucking thought about that. Let me submit this thing to it. It won't be wrong, I guess. So is it math here? This is the easy version of the problem. The difference between the versions is that in this version q equals to 1, op equals to 2. You can hack only if you solve all the versions of the problems. And in this version we have q less than or equals to 1 e power 5 and op less than op is 1 less than or equals to 2 and here is op equals to 2. Okay, you can hack only if you solve all the versions of the problem. My maturity. For a sequence S, let modulus of S denote its length. For a non-negative integer sequence C, define f of C as the sum of squares of its prefix sums. It's math. So okay, it's not math. I have to read the whole problem. I know. Define f of C as the sum of squares of its prefix sums. Okay. So for a sequence C, take prefix sum, square it. Take all prefix sums. You have prefix array. Now you just square among them, and then you have that one. That's f of C. Square sum of prefix array. Okay, let b define g of b comma m as follows. Let b be an integer sequence such that bi greater than or equals to -1 for every I, and let m be a non-negative integer. A non-negative integer sequence C is valid for b comma m if all of the following conditions hold. Modulus of C equals to modulus of b, sum of C equals to m, their sizes are same, but C adds up to m. For every integer, if bi greater than or equals to 0, then ci equals to bi. Otherwise, if bi equals to -1, then ci may be any non-negative integer. So minus ones are some non-described values, and if it is greater than or equals to 0, C should match with B. Okay, so if there are no minus ones, then B sum should be equals to M. These conditions say. If there is a -1, that can adjust now. Okay, if there is a -1, that can adjust now, and the sum should be less than M should still hold. Less than or equals to M should still hold because they're all non-negative, right? The value g of b comma m is defined as sum of C over all valid sequences C for b comma m. If there are no such sequence, then g of b comma m equals to 0. Okay, we have multiple things on here. We have a set of possible C's for a given b comma m, and we have some other function called f of C, and we want f of C over all valid sequences C. You're given an array of length n, ai greater than or equals to -1, and q queries of the following type. Given three queries, L, R, and M, compute g of AL to AR, comma M modulo. See, when the problem looks complex, that means it's a nice problem, okay? Because you have to think of a simple solution that works for this, right? So you should never get scared. You should get excited that it's a nice problem. I'm talking too much before solving the problem, but that's what it is about. Uh, Denotes the subarray A from positions L to R. So what are those Q queries? It's OP. Queries of two times. Given two integers P and V, set AP to V. Update. Given three integers L, M, and R, compute this thing and give us the answer. So we have 1 and 2. In general, we only have operations of 2 and we only have Q equals to 1. So we just have to do it once in general here. For any subarray, what are all the valid possible C's? I'll go to little bit of washroom. See, if you think of f of c, it's not that simple, right? Okay, you're expanding some of individual elements. It doesn't get too complicated, but it's not too simple either, right? Let's try to think of this f of c. In its expanded version, you will either have ci squares or you will have pairs, right? Okay? You must expand that. At least mathematically, you have to expand that because that's the simplest version you can see it, right? You can see it like c1, c2 up to so on cn plus c1, c2 plus c1, c3 plus c1, c4 up to so on, and then plus c2, c3 plus c2, c4 up to so on and so on. I mean, it's n squared, but still, let's just see that. Okay? We can see that, right? Mathematically, we can just write that down. And now, what should I be doing? I should be checking my wrong answers. Fuck, fuck, fuck. Oh, what if x1 equals to x2? What am I doing wrong here? I thought of everything, right? If you're not in the maximum distance, you will try to move towards the maximum distance possible, and then that guy will follow. So after K moves, you can no longer move, and then that guy will come and approach to you. Second guy staying in his place doesn't make any sense, right? What the fuck is going wrong? Let's just submit. Who cares about wrong answers now? Fuck, fuck. I should be getting about wrong answers. My maturity is coming. Wait. Yeah, I have to break from that outer loop. Like I'll try to read about even, but how can I? Wait. Whatever I have suspected is true. He can just stay there so that minimum distance will become either he moves or he stays there. Minimum distance will become -1 after this move. It's annoying. Wait a minute. Here I have passed 1 second, right? Here I have passed 1 second. I think I think we can solve the problems, but if we don't have practice, we make some mistakes. Is what I believe. Then, right? This is just I cannot be saying silly errors. Maybe I have to have my presence of mind. I have to understand that coding requires. See, doing CP is really important, I guess, because that gets back my critical concentration. I believe if something is wrong or not. No, this is too much. Fuck it. I'll just think of this problem. I'm annoyed. Fuck cares about this, about getting the wrong answer, right answer. If you think of f of, what can you say? F of c. Some c1 square plus c2 square, so on. And then you have c1 c2 plus c2 c3 plus and so on. Okay. You may also have c3 c2 c3 c1, or you can write it as two times. Let's write it as two times. Okay. we know this how these constants will we know how these positions will take weight, right? How many c1 squares you will get? N, right? How many c2 squares you will get? N minus 1, right? And so on. But what about these positions? How many times you will have c1 c2? It's nothing but number of times c1 c2 come together, right? Number of prefixes c1 c2 come together, right? Which would just be number of prefixes where c1 c2 come together, which is nothing but for ci times cj, it's about n minus maximum of I comma j plus 1. These many times you will have it. Okay, now think about the other problem. If frequency of minus 1 equals to 0, b must be equals to 0 equals to m, and answer equals to f of b. Else, what can you do? What the fuck? Why the fuck is this failing now? I'm getting annoyed. Oh, oh, the restriction is only on this one. Now I see it. Now I see it. If n reminder 2, she need not move aside. If n reminder 2 equals to 0, even then she need not move aside. So k minus minus is not needed because they need not move. Damn, real care is needed. This time it's passing. See, it's passing. It's passed. Now what about C1, C2, please? What can be going wrong here? See, at max you need 17, 10 powers, right? Because a less than or equals to 1 is 17, you can have d of 0 times 1 1 1 1 1 1 1 1 1 17 ones. That shit will be less than 118, I guess, and it should work out. This time. Mhm. To give you all the love that you deserve. How can I? Can this be about overflow? This is not overflow because at all stages. Give you all the love you deserve. Let me think of this problem itself. Oh, this is some other thing that I was thinking a while ago. C1, C2, C1, C3 up to so on. We know how many times these things occur, right? If you fix Cj, this thing becomes simpler because this is only being dependent on Cj. This is not that complex. Fix Cj. Okay. So now if you see Cj, okay, Cj will appear n minus j plus 1 times, and it will have, so it is linear. This is shit is easy. 2 times Cj, that's what, right? Due to even, like due to even is easy, right? 1 plus 2 up to so on. Cj minus 1. Cj Cj square plus, and what is Cj's thing? N minus j plus 1 again, because for j equals to 1 this is just Cj, right? So it is just n minus j plus 1 times Cj square plus 2 times Cj into 1 C1 plus C2 up to C2 to so on this. Okay, so Cj has these weights, but it depends on two things: the value of Cj and the sum till here. So it's about value of Cj and the sum till here. That's the weight of this, right? And you have some zeros. Number of ways some numbers add up to m minus sum of p. Cool. And Cj's value will just depend on, if you fix Cj, okay, you want number of different arrays. You don't care about number of different arrays, you only care about their sum, okay? Looks like you only care about the prefix sum, only prefix sum, and the value at Cj affects Cj's contribution. Got it? If this is Cj's contribution to the final answer, f of c, and if you're varying now the sequences, okay, let's just fix Cj and let's just fix its prefix sum. Got it? Then it's about number of such things, okay? So let's say we have number of sequences that are potentially valid, which is less than or equals to, so valid, let's say potentially valid is sum of c less than or equals to m, okay? That are potentially valid with what the fuck, with sums 0 1 2 up to so on m of length I. If you have this shit, How can you fix CI and get this one done now? Let's say you have this DP thing. How can you fix CI now? It's not simple. It's not that simple. This problem is not that simple, but it's solvable. Wait. Wait. But you have to think. It somehow it can get simplified. M is less than or equals to 10 power 6. Will that help us? See, otherwise, what you have to do is you have to get some combinatorial interpretation to this, and then you have to solve the problem. Is that possible? If I look at it like this, whatever I do, I'm trying to only think of a way where I can go over each of them, right? So if they change the array, I must compute their contributions and then I must multiply. So there is a way in which you need not look at it like this, but it is having a direction for sure. But will this direction get nullified by this number of sequences? Let's just solve for one array and think. Let's just think of the cases where minus ones are not present at all, okay? In that case, we only have one integer and we should be able to find this shitty sum somehow quickly. But how? Let's say you have this shitty sum for all the prefixes. Then you can write required as some prefix plus this whole square. Okay, if you have it till here, right? Which you can expand as p square plus this square plus 2p times of this. So from this you can get this square, which is like, now you have to do summation of this, right? Because you have summation of this. So you can subtract that and then you will have summation of these squares and then you have to subtract 2p times this one plus this 2 up to so on this, and you have to subtract. when there are no zeros itself is this complicated. Like it's not that easy. I should have solved D. I should not have touched D even, I guess. But let's think. Let's try. Let's give our best. Not lose hope still. Let's not use hope still. Because D is even more difficult than even. Maybe even is not that difficult as I'm thinking. Let me give it more time. What is this? Okay, this can be written as total prif sums minus p minus p minus p minus p times z, let's say z be the length. So yeah, this can be also computed quick. In this way we can get this square quickly. Maybe the same thing we have to do. I think likely the same thing is possible. Likely the same thing is possible. Even when there are some holes. But that's for Q2, right? For Q1 we have the array given to us. For even we have the array given to us, and all we have to do is find this quick. All valid sequences or nothing but number of sequences that will add up to b c minus b, right? So if you try to look at combinatorial interpretation of f of c, I'm not sure if I'm right or not, but let me try. It is a set as such that I one with index I, let's say you think there is a ball. So you have ball 1, ball 2. I is greater than or equals to position of ball 1. I is greater than or equals to position of ball 2. This is the only restriction. Let's look at this set. Ball 1 and ball 2 can be equal. Okay? In which case you cannot have ball 2 and ball 1. So that will just be b1 square. Right? But ball 1 and ball 2 can interchange. So let's imagine in terms of balls. Let's see that Ci as this. So this is what f of c is. So if you fix I, previously I was trying to fix the other ball, but if I fix I instead, it looks so simple, right? Am I doing something here? Am I doing something? If you fix I, it's about number of balls before I. It only that matters now. Because see this. If you fix I, let that be some of some shit. So let that be some till there, right? I'm not doing anything. That's what f of ci whole square is, right? The fuck? I'm not doing anything. I was not doing anything. I again got f of c of I whole square itself. C of I square itself. But cool, at least we got some other interpretation of this shit. Now we can at least, okay, if I fix I, it's the problem itself. So instead, let's fix balls. Can we fix balls here? I'm not sure. Do I even have time? That's what I tried doing here, right? I tried fixing two balls, and for those two balls, we'll get number of eyes like this. But varying C is not that simple. See, let's just see this shit for what it is itself and then just try to expand this a bit, okay? Let's just see. Uh, let's just see CJ square as CJ square itself. And what can we write now? Till CJ, you have some P, let's say, and holes, let them be like X holes, let's say. And after that, we have some S, let's say, suffix, let's say, and then you have Y holes there, let's say. P plus S less than or equals to M. And sum of X plus Y, sum of CX plus CY equals to M. Sorry. Okay. So far, we want count of. Okay, if you fix CX, fixing the sum till here, okay? What will you have? P plus Cx whole square is what you want, is the contribution of this, right? Now you're trying to find this one by fixing Cx, okay? And how many such things will exist is the question now. It will be, okay, with some n k positions, we know the answer, right? Some should be n k positions, means you draw k minus 1 lines and then you choosing n plus k minus 1 ck cn. So now here sum is cx, so you will choose cx minus x minus 1 cx. These many ways you can arrange them here, times cy minus y minus 1. I think it's n minus r plus 1. Sorry, n plus r minus 1. K minus 1 positions, right? cy times p plus cx square. Can you sum the above thing by varying cx? How will that look like? Because cx plus cy is constant, right? I think this is possible to sum. This shit is possible to sum because this is a bit possible to sum. Because if you see this one, it's about, not if these things are very, yeah, it's about this is fixed, but they both add up to something. You're trying to vary this thing. The two things sum is same. Now you have to think, where does this occur? Where does this occur? It occurs in 1 minus x whole power minus cx, right? Equals to. What is 1 minus x? What is 1 plus x whole power n? N into. Okay, we have this. It can be this complex, I think. See, this is cx plus 1, c2. Let me write this as x minus 1. But you're wearing CX and not you're not wearing X. You're wearing CX. Fuck it. We know an identity. We know an identity here. How can you say this identity? This identity is nothing but fixing sum, this sum, fixing this sum. The total sum is constant, right? If you fix sum, this sum, and if you fix this sum and you product them, you will get the total sum being in these many balls, right? In x plus 5 balls. So I have this identity. How can you utilize that identity and try to get this p square outside? If you get those p square outside, you can get that identity, right? I fucked up this contest, but fine. See, this p square, if it comes out, this portion is done. That portion is calculatable. I'm writing bullshit. I'm writing absolute bullshit. Yeah, this is what I want. C1 times sum of this shit plus 2py times plus sum of this shit plus z times. Now, but when you multiply with y, it becomes x times x plus. So x will become x plus 1. Okay. What would this become? X into x plus 1. But this will become x plus 2 plus 2. So now we have a closed form. 2 plus 1 plus 1, 4c. 2 plus 1 plus 1, 4c2. Agura.